Friday's lesson was on the day 1 for geometric sequences, and we found out that they definitely look very different than the arithmetic sequences that we were talking about. And that's because geometric is based on multiplication, and our arithmetic one had a plus in it because there was addition taking place. This one is going to have this multiplication piece in here. And it looks like powers because, again, we're going to multiply by the same thing over and over and over again. So that would be like raising it to a power. So Friday's lesson just got you going with that little formula so that we would know it's not going to be a lowercase d anymore for common difference. It's going to be a lowercase r for common ratio. And that's what we're multiplying by each time. And just like if we didn't know what was being added every time, and I know that's a stretch because usually we could figure it out, we could use subtraction to find what it was they were adding. In this case, because sometimes it's a little tougher to see, maybe it was a fraction they were multiplying by. So remember, you can always take any term and divide it by the term in front of it, and that'll give you r, that common ratio. So we had some formulas to add to the front cover, and I ended right here. We have a little problem about a bouncing ball, and we still need to discuss something called the geometric mean today. So using a geometric sequence, when a ball bounces, the heights of consecutive bounces form a geometric sequence. What are the heights of the 4th and 5th bounces? Well, what I want to do is figure out, well, what do I have? And what I have right now is that the first term is 100 centimeters. I have that. And this was the second one, but they didn't give me that one. So they gave me the third one. And they told me that that was going to be 49. So now my job is to figure out, well, what do I have that I could use for a formula for this so that I could go ahead and find, I know they only wanted like the 4th and the 5th. Let's go back up. Yeah, they only wanted the 4th and the 5th. But it would be nice if we could find a formula so that no matter which one they asked us for, we could give it to them. So I write down my formula for geometric. A sub n equals a sub 1 times r to the n minus 1. And the two things that we have to put into this formula are a sub 1, so we're going to plug in a sub 1 and r whenever they give those to us. If they don't, we have some work to do to figure out what they are, and then we'll get that. And that's why we needed the calculator today, is because we're going to end up taking roots, like cubed roots, 4th roots, 6th roots, those types of things. So let's see. I know the first term is 100, so I can put that in there. But I realize I don't know r. They didn't give me that. And because they skipped one up here, I have to find that. So I leave my r in the formula. And I think, well, how could I use this? I mean, just like we used it when we had arithmetic that was missing, an arithmetic sequence, we need to put those numbers in somewhere so we can find the missing r. And I notice, well, this is n. They put a 3 in. And I know what the answer is supposed to be. It's supposed to be 49. That's what's supposed to happen. Well, now I need to solve for r, but the first thing I'd do is say, well, I know what 3 minus 1 is. That's going to be an r squared right there. And then I'd have to divide both sides by 100. And then I'd have to take the square root. So the square root of both sides. This is something you might want to do on the calculator, I mean, if you're not comfortable with the fractions, because remember, you can always do math number 1 and convert it back. But hopefully you look at these and you see, hey, those are perfect squares. Now, normally, if we take the square root, we're supposed to put both a plus and a minus. But this ball is above the ground. You know, it's never going to go below the ground, so it wouldn't make any sense for us to use -7/10 for this one. So our r value should be 7/10. Now we can write the formula. A sub n equals, we already knew, bless you, that we had a 100. Now we know what r is. We know that r is 7/10 to the n minus 1. Again, I want to remind you, just like I did last week, always ask yourself, did I find what they wanted me to find? This is most of the work. This is going to get you most of the points. But we didn't find the fourth and the fifth bounce yet. That's what the calculators are for. You know, we want to put a 4 in here and a 5 in and see what we get. So we're going to need 100 times 7/10 to the third power, because 4 minus 1 is 3. Hi, Ashley, was that you?
Could I please have more time on this, please?
Did you go ahead and submit?
Yeah.
Okay, good, because then I can just unsubmit it. How about you, Katie? Yep. Do you have enough time?
Yeah, I'm just finishing up the last problem.
Great. Fourth and fifth bounce, we had both of those n minus 1 powers up there, exponents. So we use a 3 for the power on the fourth bounce and then a 4 for the power on the fifth bounce. So 34.3 centimeters. And 24.01 centimeters. And again, wouldn't want to do a lot of these geometric ones without a calculator. We're going to end up with a lot of decimal type of answers and nasty little fraction answers for these. And that's because when you multiply something, you get a really bigger number faster than adding. So that's going to give us some huge numbers eventually. Now 3a says to find the height of the 10th bounce, would you use the recursive or the explicit formula and explain? Well, it was a long 3-day weekend, so maybe you've forgotten, but for recursive, you would have to do the first, the second, the third, the fourth, the fifth, the sixth, the seventh, the eighth, the ninth, and the 10th. I don't want to do that. I'd like to just put a 10 in there. It's up to you. If you really like to do all the bounces in a row, you could say, yes, I love recursive. I want to do every single one. But most of us, I think, would say, I just want the one I have to do. So I'd use explicit. Just find the one you need. Instead of having to build up from first to second to third to fourth to wherever it is you're going. Now, we're supposed to use our formula again for B. It says, what would you get if you did the 6th and the 10th bounces? So hopefully you've got your calculators still up there. And you remember that for 6, we're going to do 6 minus 1 is 5th power. And for 10th, 10 minus 1 is the 9th power. So we need to do 5th and 9th powers. Now I do want to remind you there's a little bit faster way. You know how I've been punching each of these in individually? You can hit second, enter, and it'll pop up the last thing you typed in. And then we could just change the power. And that's a little bit faster. So we've got 16.807 for the 6th bounce. Centimeters. And the 10th bounce was, let's go with 4.035. Usually in the word problems, it'll tell you round to the nearest 10th, round to the nearest 100th, round to the nearest thousandths. And this one, they just left it up to us. So you could write the whole thing out if you want to. But the point is, with the calculator, yeah, we're going to see some nasty decimals and this kind of stuff. And yes, have a calculator handy as you work through these. So the geometric lesson from Friday was just without the words, you know, trying to get this all set up, knowing that you had to put in a sub 1 and r to get the formula, and then put your n values in once you have the formula and see what you get. Now, How about if we're only missing the number in between two others? Like in the last problem. It had a 100 for the first bounce, and then skipped this one, and it went to 49. When we had arithmetic, we could find that one by using the arithmetic mean, or the arithmetic mean. So, can there be a geometric mean? Well, of course there is. And I don't know if you guys remember this, but you actually learned about geometric mean in geometry. Is it ringing bells at all? Anybody remember? Okay, kind of, not really. So it's a good thing we're going to cover it again. So geometric mean. In an arithmetic sequence, recall that the middle term of any three consecutive terms is the arithmetic mean, or the arithmetic mean of the other two terms. We can also do that for the geometric mean. So the geometric mean of two positive numbers x and y is the square root of xy. Now, that's, some students just absolutely, they memorize geometric mean equals plus or minus the square root of xy. But I've mentioned to everybody before, I don't think that's a good way to do math, just memorizing things. My hope would be that you remember from last year that geometric mean has to do with proportions. And geometric mean is linked to extremes. Maybe that helps you from last year. Do you remember talking about means and extremes and means? Okay, some people are still like, no, that's not going to happen. So, we have 4 positions in this proportion. 1, 2, 3, and 4. When you say extremes, you mean the ones that are farthest apart. So that's the 1 and the 4. That's not the ones we want anyway. We want the geometric mean. So these are the extremes, and these two are the means. That means our little g for geometric mean goes in those 2 spots. So what do we put in the other 2 spots? Well, the 2 numbers they're going to give us, of course. That's what we're going to put in those other 2 spots. So note that the geometric mean is positive by definition, but it could be both positive or negative. While there are 2 possible values for the missing term here, 3 something, 12, there's only one geometric mean. One of them will be right. The geometric mean is one possible value to fill in that geometric sequence. The opposite of the geometric mean is the other. Because here's the thing. We know 3 times 12 is 36, and the square root of that is 6. So this could be 3, 6, 12. But it also could be 3, negative 6, 12. And they're actually multiplying by a negative for each one. So down here it says, what are the possible values of the missing term in this geometric sequence? And I remember, if one thing is missing in the middle, then we're talking geometric mean. So I need my g's in those 2 spots. And I need to take the numbers they gave me and put them in the other 2. And if that's a proportion, we always solve those by cross-multiplying. So let's cross-multiply and see what we get. G squared equals whatever 48 times 3 is. Plop that up here for everybody to see. 144, like that number. And then, remind me, bless you, how do we undo squaring? Yes, and we learned a long time ago, whenever we physically write down a square root symbol, we need to put the plus or minus piece on there. So it could be 12, but it also could be negative 12. Without more numbers in that sequence, we can't tell them. You know, we don't know if it was supposed to be positive or negative. So we have to give them both. Those are the possibles. All right. Got it 4 says, now let's make you think outside the box a little bit. We're going to give you the 9th term and the 11th term of a geometric sequence. This one is a 45, and this one is an 80. And we're going to ask you, what are the possible values for the 10th? Well, hopefully you realize they could have just asked me for the geometric mean, because they gave me 2 terms with just 1 missing in between, and that's what geometric mean does. So I need to have my g's in the bottom of the first fraction and the top of the second fraction for this proportion, because again, positions 1 and 4 are the extremes. 3 and 4, or 2 and 3 are the ones on the inside, which are the means. So let's put the 45 and the 80 here, and let's see what kind of obnoxious numbers we get for this one. Bless you. 3,600. That might not be such a bad number. So how do we undo squaring? And if you don't know it, by golly, you've got a calculator for it. There it is, plus or minus 60. So the geometric mean, is it harder than arithmetic mean? Yeah, probably a little bit, you know, because pulling all that memory from geometry sometimes doesn't happen quite so easily. Geometry is kind of a right brain to algebra's left brain, you know, so you have to put those two things together. But that's it for today. You know, we're working with the geometric sequences and we're talking about the geometric means here. Again, trying to give you plenty of time here to work in class. So this is the assignment for today, 9-3 day 2. And yeah, I have a calculator or your Chromebook handy, so you can use that TI-84 Plus app in there. But keep the homework coming. It's so nice to see so much homework coming in now through Schoology. And if you didn't do 9-3 day 1, I'd start there. You know, start with 9-3 day 1 today. You might be able... Well, you'll get at least one of them done. The other one probably halfway through. But you definitely need to do both of those so you get used to the formulas.